Hello everyone, today I'm going to do something slightly different than usual and show you one of my slightly older university homework projects following a request by Exploding Cats. But first of all, for once SpaceX has finally released the first images of the Falcon Heavy rocket in the assembly building, and a weird looking ship has been spotted owned by SpaceX lying next to the drone ship, which has been content to much debate and theorizing. I will probably talk about that sometime. I'm also still working on a video about the hypothetical concept of antimatter space propulsion, but with university and a few other projects there's not that much time for YouTube, so although I'd like to increase the frequency and quality and variety of these videos, there's a limit to what I can do. But for now, I'm going to show you a early homework project I did. As some of you may know, I am currently studying aerospace engineering at the University of Stuttgart, and I have been for a little while, so there are a few homework projects that I can show you. Now, there's a few reasons why I rarely did that before. For once, I just personally didn't think it would be very interesting. These projects are fascinating to work on and learn by, but they're not that interesting to show to you because they are mostly variations on existing airplane designs and parts, and they're usually not that well designed. They are student work, they're homework, so they're basically done in what's more or less your free time. They are made under restrictions that are just imposed for us to learn by and to test us by. And so they're usually not as good as any of the actual parts, and so you can look up much better designed and more interesting parts in any maintenance manual or just on Wikipedia. And a lot of what we're learning is just theoretical mathematics, physics, thermodynamics, there are only a few actual projects that I can show you in SolidWorks and talk about, and I'm also not allowed to show you just everything because, well, for once, to some extent, professors do have copyright on tasks they give us. There are also a few other restrictions, but for now, within the restrictions of what is allowed and what is possible and what I find slightly interesting, I will show you for this video one thing that I designed in second semester as homework that was then collected and rated equivalent to a class test. Now this task was to introduce us to what we call Strag. Now I do learn in Germany, so most of the terms I know are German, and I'm not entirely sure about English translations, unfortunately, for all of them. So I'll just go with that. But what that means is a very rough 3D model of the outer shape of any vehicle or machine where the outer shape matters, like an airplane, a space plane, a train, or anything that is aerodynamically shaped to some extent. These aren't really one-on-one accurate models as they're usually solid or, you know, just a thin skin. There are no bolts, there are no individual parts. It's just the outer shape of the aircraft. It's usually done in early conceptualization. It is good enough to do first aerodynamic studies on, and also to some extent simplified structural studies, and to get a grasp of what the concept might look like and how things might fit into there. It's also what I did for fun to some other concepts, and for example recreating the SpaceX ITS spacecraft to do aerodynamic studies on what you see when I post aerodynamic studies. But this one is an airplane, and it's a modified A330, and there was a few reasons why this one looks very weird. One of them being the very concept. This is supposed to be a successor to the Beluga plane, which is a modified A300 used by Airbus to carry airplane parts around. So it's designed to carry highly voluminous loads So it has this huge bulge essentially on top of it, which is a cargo bay. So it's supposed to look that a little bit weird, and to some degree it's just the limits of my skills at the time and the task that I was given. So it's not really a perfect design. Also, this is a simplified schematic. It's lacking a lot of things. For once, the wingspan. The wings would be much longer, but for this schematic, essentially, we cut off the wings. So in this 3D model, the wingspan is 36 meters, but they're cut off at that length. We were given wing profiles that had been previously designed as dots, basically a lot of dots with 2D coordinates, and you essentially connect the dots and get a wing profile, and we should then use these several wing profiles and put them in different distances and thus design our wing. We also got several profiles that we could use for the fins and stabilizers, which are then narrowed, but in this simple schematic they don't really have control surfaces. The main focus was to design and then visualize the main fuselage. Now if you start from the front, you can see there's a simple nose shape, the cockpit windows, which are in this case just a cutout into this hollow shape, but the rough outline of the cockpit windows is visualized. So here you can see from the side or from the front that there's a piece cut out of the fuselage, and right behind the cockpit window here is one cross section that we were actually restricted in how we were allowed to design it. In this case, just to essentially teach us something, we were free in messing around with its dimensions and proportions in order to make the plane as aerodynamic and practical looking as we could. But the basic geometric way in which it was designed was previously given to us. This is what is referred to as an egg curve. It is a little bit like an ellipsis in a geometrical way. The way it's constructed is a little bit like an ellipsis, but also a little bit different. You essentially start with two circles which can have different centers. If they have the same center, in that case it would actually be an ellipsis, but if they don't have the same center, then that's also okay, it's just not an ellipsis then. And they also have a slightly different diameter, and essentially you take the for each angle you take the x coordinate of one circle and the y coordinate of the other circle, and then you connect those dots. And we were free to choose those circles, but we had to construct it in that way. Behind that is another cross-section we were free to design, and then there comes a slightly ugly part, which is due to the limitations of this not being an actual plane design, but a homework that was designed to make us learn something. So the cross-section in front of the gearbox, the last cross-section essentially where everything still looks somewhat okay, that was predefined. The at least the lower part, the upper part we designed ourselves, but the lower part is identical to that of an actual A330, and its position and this cross section was clearly defined by the task we were given. But then the slightly difficult part is that these homework tasks are individualized. So to make it hard for us to essentially copy from each other, the tasks get a number key. There are a few specifications to the task, a few parameters that can be changed as basic variables, as basic numbers, and then a few number keys are randomly generated, so that although the general overall task is the same, each student's task is in detail a little bit different, and these are randomly generated and are not really checked over very carefully, and to some degree they are also just made difficult so that the airplane design might not end up being that great, but at least we learned something, because that's the main priority here. So in this case, The gearbox of the plane, the mechanical box where the mechanisms for the landing gear and the landing gear itself are stored in, has been shifted a little bit. It's not the one from the original A330, but it's changed. It's a little bit bigger. It's a little bit further ahead. And so together with that predefined cross-section, that just gave this fast jolt of cross-section, because if I just continued that predefined cross-section further to the tail, then the gearbox simply wouldn't have fit inside. So I had to vary that cross-section, but because the gearbox was very close to that cross-section, I had to vary the cross-section very suddenly, which never looks good and is never really aerodynamically great. But while I could probably do a little bit better nowadays, I did it as good as I could at that time, and that was pretty much the point of it, to see how good we could deal with that problem. And as the grading showed, even back then I did well enough to be acceptable. Slightly further back we start to see the wings, which were also somewhat predefined by parameters. We were given actual wing profiles in the form of several dots that we could connect, and we were given basic definitions of the wingspan of the airplane and how deep the wing should start based on the actual A330, but then free-formed the wing out from there. And as you can see, there is also a marked line where the wing intersects with the fuselage, or where it's basically connected to the fuselage. You could slightly round that, but we weren't supposed to do that. Yet still it gives you this nice auto-generated 3D curve hogging that wing profile there. And the wing narrows into another profile and yet another profile, and then it's cut off early at 36 meters of wingspan. The cross sections here are freely designed by us. They do of course have to accommodate the gearbox as well as the payload cargo bay, and of course they were rated by how well they would actually work, how aerodynamic they would be, and how practical they would be. At the tail rods end of the gearbox you can see a slightly nicer transition, because here we didn't have such close predefined cross sections, so it was a lot easier to make a somewhat aerodynamic slope from the gearbox into the rest of the fuselage. And then we were approaching the tail. Here the upper halves of the cross section were previously given, and we had to freely design the lower halves. Then we'd get to the tail, where we have the stabilizer and rudder, which are based on the profiles used by the actual 330, and obviously also narrow down to a slightly different profile at the tip. And the tail is also slightly cut off at the end. This was also part of the task. The tail should be cut off and should end in this exact ellipsis, making the overall schematic 85.8 meters long and giving it a wingspan of 36 meters, although of course the wings are cut off. The lines you see within the model are partially indicators for where the insides that we had to accommodate lay, so the gearbox and the payload bay. Then there are of course the cross sections we designed, as well as the profiles for the wings and the stabilizers. Then there are the lines where the wings and stabilizers meet the fuselage, and there are lengthwise cross-sections that are cross-sections of the airplane taken through planes that are on the lengthwise axis but rotated around different degrees. And these do look slightly weird here. They usually look a lot nicer for normal airlines, but yeah, since this is a somewhat weird looking airplane, they do also end up looking a little bit strange, curving back and forth at some points, because the fuselage is actually indented at a few points. And around the gearbox there are a few places where these lines get so close to each other that that actually caused a little bit of trouble, because we had to basically print this out as a kind of blueprint, you might say. It's of course not actually blue, but as a plotted big sketch, and the lines had to be of a predefined thickness, and that means of course if the lines get too close, they just merge into one black surface, and we are not allowed to change the thickness of the lines. So you could try to change the design so the lines wouldn't get that close, or you could just live with the fact that you had that one black surface instead of separate lines on your design, and either way it wasn't really pretty, but it was acceptable because there wasn't really any way to avoid it. In an actual airplane design project, you would most likely just make a little window in your sketch and essentially zoom into that particular area. But here we weren't allowed that, so we had to go with black areas where these lines just merged because they were too close. Either way, apart from the little gearbox dent that you have at that front end of the gearbox, I'm generally rather happy with the aerodynamic design of this thing. I hope you found this somewhat interesting, and if you're interested, I will also present a few slightly more complicated things that I did, though those might take a little longer to make. I'm still open for any questions, although I am a little bit busy right now, so I probably can't make a video about them right away, but I'll try to basically catch up with that, and I'll definitely answer them eventually. So this is it for today, and as always, thanks for watching.